Hello and welcome to a new video on IGC SE Mathematics. In this video, we shall be discussing vector geometry and we will be dealing with advanced problems. In the diagram, O is the origin, OA equals A, OC equals C, and AB equals B. P is on the line AB so that AP to PB is 2 to 1. Q is the midpoint of BC. Find in terms of A, B, and C in its simplest form. CB, the position vector of Q, and PQ. Of course, you need to have watched the basic questions video first before watching this video, as this video deals with more advanced problems. So we will be solving at a faster pace. Now, we are given that P is on the line AB and that AP is double PB. So P is somewhere here. And we can also position Q as the midpoint of BC. So Q is somewhere here. So this would be Q, and these two parts would be equal to each other. And then we are required first to find CB. So CB is very straightforward. You go from C to B. So CO plus OA plus AB, which would be negative C plus A plus B. Next, we want to find the position vector of Q. So this would be OQ, and this would equal OC plus CQ. Now we need to get CQ, so we need to utilize the idea of the ratio. So we have a segment and a segment and a big segment, the total. So we can write CQ, QB, and CB. Since these are equal, we write them as 1 to 1, and CB is the total, so it's 2. And then we are interested in CQ, so we can write CQ as half of CB. Now CB has already been obtained, so CQ is equal to half times negative C plus A plus B, based on the answer to question A. So negative half C plus half A plus half B. And we can write this down in the problem. So we have OC plus CQ. OC, of course, is just C, and then plus CQ, which is negative half C plus half A plus half B. So the final answer, after simplifying, C minus half C would be just half C and half A and half B. Now we're done with question B. Finally, we need to find PQ. So PQ would be equal to PB plus BQ. Now, in order to get PB plus BQ, we would have to first find BQ. We already have BQ in the ratio. So we can say that QB equals half CB as well. And therefore, QB equals half or negative half C plus half A plus half B. This is similar to CQ, of course. So we can just plug these into the equation for QB. Of course, here we have BQ, not QB. So we will change the signs of everything. So we will have half C minus half A minus half B, because it's the negation of QB. And for PB, we need to construct the ratio as well. So we have PB and AP and AB. So we can write the ratio AP to PB to AB. We are given that AP to PB is 2 to 1, and the total is 3. We are interested in PB, so we're going to link PB to the total. So PB equals 1 over 3 AB, and PB will equal simply 1 over 3B because we already know that AB is equal to the vector B. So we can write PB as 1 over 3B. And we add them up and we simplify. So we have 1 over 3 minus half. That would give us negative 1 over 6. So negative 1 over 6B plus half C minus half A. And that would be the final answer. Let's circle our final answers. And let's compare to the marking scheme. So negative C plus A plus B is correct. Half A plus half B plus half C is correct. And half C minus half A minus 1 over 6B is correct as well. So the three answers are fine. And we will move on to the next problem. In the diagram, O is the origin, OC equals negative 2A plus 3B, OD equals 4A plus B. Find CD in terms of A and B in simplest form. So in order to find CD, we're going to first write it as CD equals CO plus OD. Of course, CO is the same as negative OC. So CO would be negative, and we will write the expression for OC, which is given in the problem, as negative 2A plus 3B, and then plus OD, which is 4A plus B. So let's simplify. Here this becomes 2A minus 3B plus 4A plus B. So we get 6A minus 2B as the final answer. In question B, we are told DE equals A minus 2B. Find the position vector of E in terms of A and B in simplest form. So actually, this is an easy question. It's not very advanced or anything. It just looked a bit different. So this is why I put it in this video. But it turns out it's an easy question. So anyway, we want the position vector of E. So we have OE equals OD plus DE. And OD is 4A plus B. And DE is A minus 2B. So we simply add these up and we get 5A minus B. So we have our two final answers. So 6A minus 2B is correct and 5A minus B is correct as well. In the diagram, M is the midpoint of AB and L is the midpoint of OM. The lines OM and AN intersect at L, and ON equals 1 over 3 OB. Find in terms of A and B in simplest form, OM. So in the previous video, we had a similar case and we derived how to find OM. I'm going to derive it and then I'm going to tell you about a shortcut that we can use. In fact, I'm going to do the opposite. I'm going to tell you the shortcut first. The answer to this is just going to be half A plus half B. How did I find this out? There is a theorem that says that if you have two vectors, A and B, and then you have this line here like this, and you have a vector going through the middle and cutting the third line at the midpoint, this vector C is going to equal half A plus half B. So if you don't know this theorem, that's fine. You can actually derive it, and I'm going to do that right now very quickly. But I just want you to know that there is a shortcut here that you can use. So anyway, let's solve in the traditional way. We are given that M is the midpoint of AB, and we want to find OM. So solving in the traditional way, we would say OM equals OA plus AM, and OA is equal to A, and then AM, we will need to find that, and AM can be thought of in terms of segments and ratios. So we have this segment here and this segment here, and the total segment. So we can write a ratio AM to MB to AB. Now, since the M is the midpoint, so this is 1, 1, and 2, we are interested in AM, so we will link that to the total. So AM equals half AB. AB would be going from A to B, so we would go AO and then OB. So that would be negative A plus B. So therefore, AM would be the half of that. So we have negative half A plus half B. And then we would put AM back into the equation. So we would get negative half A plus half B. And that would give us half A plus half B. Of course, this is the same final answer that we got using the shortcut. You can know both, no problem. In B, we want to find OL. So we are given that L is the midpoint of OM. So we can use ratios again. L is the midpoint of OM. Again, the shortcut here is just to understand that since L is the midpoint, OL is just half of OM. So it's half of the previous answer. I'm just going to teach you the quick techniques and the slow way as well. And you can use whichever one you want. So the answer here, the quick answer would be half times the previous answer. And that would just give us quarter A plus quarter B. If you want to do it in the traditional way, you would say, we want to go from O to L. And then you would do the ratio OL to LM to OM. Since L is the midpoint, so we can say 1, 1, 2, and OL equals half M, half OM. And then again, you substitute OM for the previous answer that we got in A, and you multiply by half, and you will get the same answer. So either you do it in the ratio way, or you just figure out that it's half of OM mentally. Finally, we want to get AL. So AL is simple. We're simply going to get AO plus OL. So AO is negative A, and then OL is what we got in question B. So this is quarter A plus quarter B. So we have negative 3/4 of A plus 1/4 of B. So we have this answer here and this answer here. These are the final answers, as well as this one here. So these are the three final answers. Finally, we want to find the ratio of AL to AN in simplest form. So in order to get this ratio, we need to first find AN. So how do we get AN? We need to say that AN is equal to AO plus ON. And AO would be negative A, but we need to get ON. So we're going to have to use ratios to get ON. We are given that ON is 1/3 OB. Actually, again, this doesn't really need ratios because OB is simply B. So you can just write ON as 1/3 B, and that would be AN. So if we want the ratio of AL to AN, AL is negative 3/4 A plus 1/4 B, and AN is negative A plus 1/3 B. You have to understand that AL and AN are parallel, so it just has to be like a number. The ratio has to be a number, 1 to something, or something to 1. So all you have to do is just figure out how the ratio here is affected. So the ratio here is negative 3/4 to negative 1. You can multiply by 4. You would get negative 3 to negative 4. You can multiply by negative 1. So you would get the ratio as 3 to 4. So the ratio of AL to AN would be 3 to 4, and that would be the final answer. So for the first one, half A plus half B is correct. For the second one, quarter A plus quarter B. For the third one, quarter B minus 3/4 A. And for the fourth one, 3 to 4 is the correct answer. OPQR is a rectangle and O is the origin. M is the midpoint of RQ and PT to TQ equals 2 to 1. Find MQ, MT, and OT. So since M is the midpoint of RQ, instead of doing ratios, we want to do the quick way now. M is the midpoint of RQ. We can just write that RM equals half MQ. And we can also write, equals half RQ. And we can also write MQ equals half RQ. Now, we want to get MQ, so MQ is half RQ. How would we get RQ? RQ is simply P, because RQ is parallel to OP. So, since this is a rectangle, they are parallel and congruent, so therefore RQ is simply P. So therefore MQ would be half P. Next, we want to get MT. So MT would be MQ plus QT. We already have MQ, so this is half P, but we need to get QT. So we need to find QT. Now, in order to find QT, we're going to utilize the ratio here. We have PT and TQ. So we have a segment PT, a segment TQ, and the total segment. We can write down the ratio. PT to TQ to PQ. And we are given that PT to TQ is 2 to 1, so this is 3. We are interested in QT, so we're going to link TQ to the total. TQ is 1 over 3 PQ. And PQ is equal to R because this is a rectangle, so this is 1 over 3 R for TQ. Therefore, QT is going to be simply negative 1 over 3 R. And that's it. That would be the final answer. Finally, we want to find OT. So OT would be OM plus MT, I'm sorry, OR plus RM plus MT. Now, OR is simply vector R. RM is half RQ, which we said this is equal to half P. And MT is half P minus 1 over 3 R from the answer to double I. So this would be half P minus 1 over 3 R. Now, R plus half P minus 1 over 3 R would be 2 over 3 R plus P. Finally, in question B, we are told RQ and OT are extended to meet at U. Find the position vector of U. So let's extend as they said. So we are given that OT and RQ are extended. So let's just draw 2 lines like this. And they meet here at point U. We want to find the position vector of U. So the position vector of U is OU. And this position vector is equal to 2 different things. Since, first of all, it is parallel to OT, so we can say that it is equal to a constant that we don't know multiplied by OT. And then at the same time, vector OU can be obtained by going from O to R and then from R to U. So we have an equation, either K times OT or OR plus RU. So let's try to solve this equation. So we have K times OT, and we already know OT, which is 2 over 3 R plus P. This is equal to OR, which is basically R, plus RU. Again, RU is an extension of RQ. So therefore, RU is an extension of vector P, because let's look at the drawing. You have vector RU, and you have vector RQ. This is P. So this must be a multiple of P. We will not use the same letter, so we won't use K again, but we can use any other letter. Let's say M times P. It's parallel. They are parallel vectors, so it's just a multiple of P. So we're just going to say that RU is simply MP. Now we can expand and we can say that 2 over 3 KR plus KP equals to R plus MP. Now, I want you to differentiate between constants and vectors. So this R and this P, these are vectors. And then K and M, these are constants. So we have two equations here that we can equate to each other. For the R, we have a separate equation. Here we have 2 over 3K. Here we don't have anything, so we just assume that this is 1. So we can say that 2 over 3K equals 1. And at the same time, here we have Kp and Mp, so we can just say that K is equal to M. Now, from the first equation, if we take the fraction to the other side, K equals 3 over 2. Therefore, M equals 3 over 2 as well. So the final answer can be obtained by plugging K into one of the equations. So we can just plug K here. So we have 3 over 2 times 2 over 3R plus P. If we distribute the 3 over 2, of course, 3 and 3 cancel out, 2 and 2 cancel out, so you have R. And then for the other one, you have 3 over 2 P. So this would be the correct final answer. So the first answer is half P. The second answer is half P minus 1 over 3R. The third answer is P plus 2 over 3R. And the final fourth answer is R plus 3 over 2P. It seems that we have obtained the correct answers for this question. ABCD is a parallelogram with AB equal to Q and AD equals to P. ABM is a straight line with AB to BM equals 1 to 1. ADN is a straight line with AD to DN equals 3 to 2. Write MN in terms of P and Q in the simplest form. So let's begin by finding MN. So MN is equal to MA plus AN. Now we are given ratios to find MA and AN. First of all, we know that AB to BM is 1 to 1. So we have a segment here and a segment here. We can construct a ratio. So we have AB to BM to AM. And this is 1 to 1 to 2. Now we are interested in MA, so we're interested in AM. We already have AB, so let's link these together. We can say that AM equals to 2 times AB. So AM equals to 2 times Q. So now that we have AM, we can figure out MA quite easily. MA is going to be negative 2 times Q. And we are left with AN. So how do we get AN? Using the same logic again. We have AD and DN as segments. And then we have the total segment here. So AD to DN to AN. We have 3 to 2 to 5. We are interested in AN and we have AD. So we can express them as AD equals 3 over 5 AN. Or AN equals 5 over 3 AD. And AD is equal to P. Excuse me. So AN equals 5 over 3 times P. You can write this down as AN here. And that would be the answer to MN. So this is the first answer. In B, we are told the straight line NM cuts BC at X. X is the midpoint of MN. BX equals to KP. Find the value of K. So we want to find the value of K such that BX equals to KP. Whenever you have an issue with multiples of vectors, you need to find two equations and equate them together. So first of all, you are given that Bx is equal to Kp. So you need to find another path from B to X. So you have this path here from B to M and then from M to X. So let's write down Bx as Bm plus Mx. Now we are given that X is the midpoint of Mn, so we can construct a ratio again. Since X is the midpoint, we have this line here and this line and the total. So we can say that Mx to Xn to Mn is equal to 1, 1, 2. We are interested in Mx, and we already have Mn. So let me write this answer in a proper place so that we can refer to it easily. So this is the answer to A. Let me just write it here. We can write Mn equals negative 2q plus 5 over 3p. This is the answer to question A. Now, we have Mn and we are interested in Mx, so let's just link these together. So Mx equals half times Mn, and this is equal to half times negative 2q plus 5 over 3p. And this would be negative q plus 5 over 6p. I just distributed the half over the two terms. So we have Bm as well. So Bm is equal to AB. We already have that from the first ratio. This is Bm here, and this is equal to AB. So AB is Q, so Bm is Q as well. Now, since we have Bm, we can just write Q, and Mx would be negative Q plus 5 over 6p. So therefore, Bx equals Q plus negative Q is 0. So this is equal to 5 over 6p. And therefore, the constant K is equal to 5 over 6. Let's check the marking scheme. We have 5 over 3p minus 2q for the first one and 5 over 6 for the second. In the diagram, OABC is a parallelogram. OP and CA intersect at X. CP to PB is 2 to 1. Find OP in terms of A and C in its simplest form. So we have a ratio here, CP to PB equals 2 to 1. So we have three segments again. CP to PB to CB. We have 2 to 1 to 3. So CP is equal to 2 over 3 CB. And CB is equal to A because it's a parallelogram and these are opposite parallel sides. So this is 2 over 3 times vector A. This is the value of CP. We want to find OP, so this is simple enough now. OP equals OC plus CP. And this is equal to C plus 2 over 3A. These are the vectors that create vector OP. In question B, we are told Cx is equal to 2 over 3 XA, or Cx to XA is equal to 2 to 3. Find OX. So we are given a ratio. Let's use that as well. Cx to XA. Of course, the total here, excuse me, I apologize. So we have Cx to XA, and the total would be Ca. And the ratio would be 2 to 3 to 5. Of course, Ca can be obtained as CO plus OA, so negative C plus A. And Cx would be 2 over 5 Ca. And that would be negative 2 over 5 C plus 2 over 5 A. I just multiplied this vector here by 2 over 5. So now that we have Cx, we can get Ox quite simply because Ox is simply equal to OC plus Cx. So OC would be just C, and then plus Cx, that would be negative 2 over 5C plus 2 over 5A. And we can simplify, of course. So this would be 3 over 5C plus 2 over 5A. And that would be the final answer for question I. Now we want to get the ratio for OX to XP. So we can construct the ratio in terms of OX to XP to OP. And we already have OP. OP is C plus 2 over 3A. And we have OX, which is 3 over 5C plus 2 over 5A. So we can simplify the ratio by just choosing one of the variables. So you have 3 over 5 here to 1. We are interested in OX to XP. So you can either split it first or multiply first. Let me multiply first to make life easier. If I multiply here by 5 on both sides, I get 3 instead of 3 over 5, and I get 5 here. And the missing ratio, of course, would be 2. So therefore, the final answer would be 3 to 2. So the first answer is C plus 2 over 3A. Second answer is 3 over 5C plus 2 over 5A. And the third answer is 3 to 2. OAB is a triangle, and ABC and PQC are straight lines. P is the midpoint of OA. Q is the midpoint of PC. OQ to QB is 3 to 1. OA is 4A, and OB is 8B. Find, in terms of A and or B in simplest form, AB. So to go from A to B, we can go as AO plus OB. So since we already have OA, so this would be negative 4A plus OB, which is 8B. And we're done. That would be question I. Next, we want to get OQ. So we have OQ here as a ratio. Let's construct the proper ratio now. So we have OQ to QB, and the total segment would be OB. And the ratio given is 3 to 1, so this would be 4. So we're interested in OQ, so let's link that to the total. OQ equals 3 over 4 OB. Can we get OB? Yes, we can. OB is actually 8B, it's already given. So that would just be 3 over 4 times 8B. And you can simplify, you get 6B. So OQ equals to 6B. Let's write that down as the final answer here. Finally, we want to get PQ. So PQ is PO plus OQ. We already know OQ, so something plus 6B. This something is the PO. So let's try to get PO. Now we are told that P is the midpoint of OA. So since P is the midpoint, we can say that PO is half of the entire thing. So PO equals half times AO. AO is negative 4A because it's the opposite of OA. So we get negative 2A for PO. So we put negative 2A here. And the final answer would be negative 2A plus 6B. This would be PQ. By using vectors, find the ratio AB to BC. Now, in order to find the ratio of AB to BC, we need to find an alternative path from A to C. So for example, let's consider AC as AO or AP even plus PC. Now AC is an extension of AB. We don't know what that extension is, so we can write KAB, for example. And then AP is something that we have, so let's keep it as it is. And PC is an extension of PQ, and we know exactly what the extension is because we are given that Q is the midpoint of PC. So we can say that PC as a total is equal to 2 times PQ. So this would be just 2 times PQ. Now let's write down the vectors. We have K, and then for AB, this is the answer to I. So this is negative 4A plus 8B. And then this is equal to AP. And we already know AP because AP is simply the half of AO. So half of AO would be negative 2A. Let me show you this on the drawing. So AP is this part. So it's half of AO because P is a midpoint. So that would be negative 2A. And then we have 2 times PQ. And we have PQ already from triple I. It's negative 2A plus 6B. So let's expand and simplify. On the left-hand side, we have negative 4KA plus 8KB equals negative 2 negative 2A, I'm sorry, minus 4A plus 12B. So we have negative 6A plus 12B. You can use either the A or the B, it doesn't matter. The number next to the A has to equal the number next to the A. So negative 4K equals negative 6. So therefore, K equals to 1.5. So therefore, we can say that AC equals to KAB, which is equal to 1.5 AB. So AC to AB is equal to 1.5 to 1. So therefore, AC to AB, if we multiply by 2, that would give us 3 to 2. Now we want AB to BC. So remember, these are two segments. So we have this segment and this segment here. And the total is AC. So now all you have to do is just add BC here. And we remember that the big one is AC. This is the total. So this would just be 2 to 1. And that here would be the final answer. So for I, we have negative 4A plus 8B, which is correct. For double I, we have 6B. For triple I, we have negative 2A plus 6B. And finally, we have 2 to 1 for question B. Moving on to the final problem in this PDF or in this video. OAB is a triangle and C is the midpoint of OB. D is on AB such that AD to DB equals 3 to 5. OAE is a straight line such that OA to AE equals 2 to 3. OA equals A and OC equals C. Find AB. So to get AB, that would equal AO plus OB. AO is negative A. OB would be a multiple of OC. Now we are told that OC is the midpoint, and I'm sorry, we're told that C is the midpoint. So we can just understand that OB is double OC. So OB would simply be 2C. So therefore, here we have 2C. So AB would be negative A plus 2C. That would be the answer to A. In B, we are required to find AD. So let's figure out the ratio. We have AD to DB to AB. AD to DB is 3 to 5. This is 8. And we are required to find AD. So we want to link AD to AB. So AD equals 3 over 8 AB. We already have AB, so we just multiply the answer by 3 over 8. We get negative 3 over 8 A plus 3 over 8 times 2, which is 3 over 4 C. I just multiplied the previous answer by 3 over 8. Next, we want to find CE. So to get CE, I'm going to use another path. So I'm going to use CE equals CO plus OE. CO is just negative C. We want to get OE. We're going to use this ratio here. So we have OA to AE equals 2 to 3. And we can add the total segment. So we have OA to AE to OE. And this is 2 to 3 to 5. So OA equals 2 over 5 OE. Since we are interested in OE, we can rewrite the equation as OE equals 5 over 2 OA. Of course, OA is just vector A, so we can write this as 5 over 2A. And that would be the answer to question C. So negative C plus 5 over 2A, that would be the answer to question C. Finally, for question D, we are required to find CD. Now CD would equal CO plus OA plus AD. CO, as we said, is negative C. OA is simply A. And we want to find AD. AD will be found using this ratio here. So we write, actually, we already have AD. I apologize. We already have AD from the solution to question B. So the second circle. So this is negative 3 over 8A plus 3 over 4C. And you can simplify. So A and negative 3 over 8A, you get 5 over 8A. Negative C and 3 over 4C, you get minus 1 over 4C. So the answer to question D would be 5 over 8A minus 1 over 4C. This is the fourth answer. Now for double I, you are given that CE equals K times CD, and you are required to find the value of K. So CE is a multiple of CD. Let's draw that on the drawing. So we have CDE like this, and we want to get CE as a multiple of CD. The trick is always to go from C to E in an alternative path. So we're going to go from C to O, and then from O to A, and then from A to E. So in order to solve this, we're just going to say that CE equals CO plus OA plus AE. Now, CO, as we said before, is negative C. OA is A. And AE is what we're missing. How do we get AE? So in order to get AE, we're going to need to utilize the 2 to 3 ratio. We already have that written above. We just need to find AE in terms of OE or OA, it doesn't really matter. We have OA, so let's just use OA instead. So let's use this ratio here. We can say that OA equals 2 over 3 AE. So AE equals 3 over 2 OA. And OA is just A, so AE equals 3 over 2A. This is the value of AE. And we plug it into the equation. So we have 3 over 2A here, like this. Now we have negative C plus 5 over 2A. This would be the value of CE. Now we already have CD. CD is given in D, question D, as 5 over 8A minus 1 over 4C. So you can either compare the numbers on A or the numbers on C. You will get the same ratio anyway. So we just write a ratio here, CE to CD. For C, for example, here we have negative 1. And here we have negative 1 over 4. we can multiply both sides by 4. So we get -4 to -1, and we can remove the negatives or multiply by -1. So you get 4 to 1 as the final answer. Just so that you are convinced that it doesn't matter, let's also try to find the ratio using these two numbers. So we have 5/2 to 5/8. Now let's multiply both sides by 2, for example. This would be 5. Okay, let's multiply both sides by 8. That would be easier and faster. So I'll multiply here by 8 and I'll multiply here by 8. These would cancel out and these would give me 4. So I get 20 to 5. Divide by 5, you get 4 to 1 again. Of course, here I just wrote 5/2. So this is CE to CD. So this is also 4 to 1. These are the same answers, regardless of whether you use A or C. Let's check the marking scheme. So -A plus 2C is correct. -3/8A plus 3/4C is correct. 5/2A minus C. And then 5/8A minus 1/4C. And then the ratio is 4 to 1. This is also correct. This brings us to the end of our video. I hope this has been beneficial. Thank you for watching.